Let's take a look at the first of our examples of how to find the first derivative of a polar curve. Here we want to find the slope of the tangent line to the circle given by the polar equation r equals 4 cosine theta at the point where theta is equal to pi over 4. Recall how our derivative formula for the first derivative of a polar curve goes. Hopefully you remember deriving the formula for dy dx of a polar curve from the product rule applied to those little rules we know related to polar curves, that y is equal to r sine of theta and x is equal to r cosine theta. Dy dx then is given by dy d theta over dx d theta, and that's where we applied the product rule on those little equations to obtain the formula for dy dx. And that is what we are going to substitute into for here. Let's simply find our expression first for dy dx, and then we'll substitute in theta equals pi over 4. Applying the rule, we have the r, which is 4 cosine theta, times cosine theta, plus, now we need dr d theta, which simply is r prime, which is 4, and derivative of cosine, of course, is negative sine, so we have negative 4 sine of theta. And that's what we're going to use for our dr d theta as we substitute in. And then that gets multiplied by sine of theta as well. In the denominator, we have negative 4 cosine theta, the negative r value, times sine of theta, plus, and we have our dr d theta again, this time multiplied by cosine of theta. So let's simplify and combine a little. You'll notice we have some cosine squareds and we have some sine squares. And in the denominator, we have negative 4 cosine theta plus another negative 4 cosine theta. So we'll be able to combine those as well. That then gives us 4 cosine squared of theta minus 4 sine squared of theta over negative 8 cosine theta sine of theta. Let's now find the specific derivative then, where theta equals pi over 4. This is where you need to know your unit circle values. So we have 4 times, now the cosine of pi over 4 is 1 over root 2. When we square that, we get a half, minus 4 times sine is going to be the same. You can already tell that numerator is going to come out as 0, but just to finish it out, this of course simplifies to 0, which indicates that we have on the graph a horizontal tangent line. So let's go ahead and look at the graph of this, and we'll confirm that at theta equals pi over 4, we do indeed have a horizontal tangent line. If you switch over to your calculator, let's go ahead and put it in polar mode. Remember, you'll hit your mode button, and then the line down that says function parametric, and there is polar. So simply go down to that line and select polar. You'll see that the black box darkens over it when you do. And now when you hit y equals, remember that instead of having y1, y2, etc., you're going to have r1, r2, r3, etc. So our curve for this one was 4 times cosine of theta. Remember now when you hit that X button, you get a little theta. And we're going to go ahead and do zoom trig, which is zoom 7. That puts our values in terms of pi on the horizontal axis. And this would be a circle because of the aspect ratio. It doesn't quite look like one. Now, to check and confirm that at theta equals pi over 4, we do indeed get a slope value of 0, what you can do is second trace your calculate menu. Remember, when you're under the regular rectangular menu, this is where you'd have your value, your intersection, your roots, your max mins, etc. You'll notice now this menu changes once you're in polar form. We want dy dx, so go down to line 2, hit enter. You can now enter in pi over 4 for the angle, and you'll notice it enters it in at the bottom for you. Hit enter, and there's your derivative, dy dx. Notice how close this is to 0. This would be negative 0.70, then 8335. So that's pretty darn close to 0. So checking these on your graphing calculator is very much an option. You can see that there's another location, obviously, where your slope would have been 0 at the bottom of the circle, but we had specifically been asked here to find the slope at theta equals pi over 4.